Everyone hear me okay? I'm really quiet, so, just joking. So my name is Grant McAllister. I work for AWS. I work on our relational database service, or RDS. I'm an actual engineer. At least I play one on TV sometimes. I helped found RDS about 7 or 8 years ago, and it's been very exciting to see it grow. And my favorite engine on RDS by far is Postgres, and that's what we'll be talking about today. Sort of the things we've released over the last year and the changes we've made based on customer feedback and customer asks, as well as the lessons we've learned in working with customers over that period. So let's jump right in. So as of yesterday, we just released a whole bunch of new minor versions. And earlier in the year, we announced support for Postgres 9.5. So yesterday, we released 9.5.4 and also 9.4.9 and 9.3.1.4. So those are your standard, typical Postgres releases with all the fixes and stuff in them. We also enabled some new functionality that I'll get into later with some of these releases as well. So one of the things that we've done with the recent shipments is to add more support for extensions, IPv4, PG buffer cache, and PG stat tuple. The last two are really quite critical. We got a lot of feedback from our customers that said, look, to manage large databases, I need to be able to see what's in my buffer. I need to be able to examine how I'm doing on my shared buffer setting. And we'll talk a little bit more about that later. And PG stat tuple is just a great extension that really allows you to see what's going on with the stuff stored in the database. And of course, we added with 9.5 a whole bunch of the ones included in the core, distribution, and I won't go into every one of those, but it's obviously useful. And we've been slowly over time adding more and more extensions. We started with 32 in our original 9.3 release. That's now 35. With 9.4, it's 39. And with 9.5, it's 44. So the future is going to be more. Obviously, 9.6 has some ones in it that we'll be including. But if there's ones that you want to see in RDS, if you're like, I'm blocked because you don't have extension X, please feel free to send us email to that extension, RDS Postgres extensions request, and we'll add that to the list of the things that we're examining. I know PG Partman, for example, we're getting a lot of emails on that one now, and it's great to see that kind of request because then we know that that's valuable for us to go and invest time in. One of the other things that has changed with 9.5 is the parameters around checkpoint segments. And this was very helpful for us because we start out with a default of 16 checkpoint segments. So that's essentially 256 meg. So what happens as you're writing along, if you have your checkpoint timeout set to 5 minutes, is you start using these segments. Well, when you use them all up, basically it's going to checkpoint. And so we had a lot of customers that would just come to RDS and they would start using it and they'd be checkpointing every 10 seconds with 256 meg. But on the other hand, we also have customers that come and buy very little storage, and we didn't want to make the checkpoint segments many gig because we'd be using up the space that they bought for essentially nothing. With 9.5 and above, now we have two new parameters: min wall size, which is essentially like checkpoint segments in that that's the starting value, and max wall size. So in that same sort of model, we have you use up the 256 meg, but instead of checkpointing, now you'll just continue to increase your segments until you grow out to essentially that whole 2 gig. And at that point, you're going to checkpoint. So what's nice here is now you won't use a lot of excess space, but you'll get much less frequent checkpoints. And as Andreas was just saying in his talk, really you want your checkpointing to occur more like in the 5-minute or greater range, depending on your recovery targets that you can deal with, because it really does reduce the amount of wall you're writing due to the full block logging. The other thing we changed is we changed a lot of parameters in 9.5. We changed a bunch of defaults. So we added a thing called RDS Super User Reserved Connections. How many people have used Super User Reserved Connections in their Postgres instance? A few, yeah. So this is your safety net. This is when your application has just overwhelmed your database with connections, and you've hit max connections and you can't get in. So what we did was we added the RDS equivalent, so now you can get in with the RDS super user during one of those times and kill it off. But when we introduced this in 9.4, it was in the middle of 9.4, and we didn't want to make that change, to be an actual change for folks. So we set it to 0 to start with. You can obviously change this to 2, but with 9.5, we're starting with a default of 2. That does mean your number of total max connections will be slightly smaller because of those two, but in general, this is a good safety net. The other one that we got a lot of comments on from our customers was our max connection setting. In 9.3 and 9.4, basically we took, and said, we used this formula that said, hey, how much memory divided by a certain number, that's how many connections we start with by default. And it worked for a bunch of the instance classes, but not a great fit. Now what we do is we actually say, we're going to start with more connections, but we're going to cap it at 5,000. And so this is what it looks like for our different instance classes. And you can see on, like, the old is yellow and the new is blue. So on the T2 micro, we used to start with, I think, some number that was like 16 or something. And people were really confused because they said, can I only have 16 connections on a T2 micro? We're like, no, you can have more. So now we set it to a much more reasonable, slightly above 100. And you can see how it increases with sort of the size of the instance. And the big change here is that, on the big instances, if you look at the R38XL at the far right there, we used to set it above 8,000. And people are like, look, really, I don't need that many connections. So now we cap this at 5. And one of the good things is we explore going to larger and larger instance classes. For example, like EC2's X1 instance that has 2 terabytes of memory. We would ended up like setting max connections to 50,000 or some goofy number. So this is a much more sane sort of setting. And again, you can modify these yourself for whatever you need, but that's where we started with. The other one we heard a lot of comments on was about maintenance work memory. We had started with the default of sort of 16 meg in the 9.3 days, and a lot of our customers didn't change this. And then so when they would go do vacuuming or index builds or other things, they were like, wow, things are really kind of slow. So we upped that to 64 meg, but we didn't want to make it too large because, again, we have these very small instance classes. But now, again, we've got a more complex formula that we can use to calculate. So you can see now with new parameters, we actually set it to a larger value to start with, and then we grow it up, and I'll show you how that goes. The one note here is that if you're running a 9.3 or 9.4 instance, you'd actually have to create a new parameter group because we didn't update these on the existing ones. So again, you'll see in the sort of orangish yellow there is the very existing one. You can see how small that was, that are 9.4, and then the current one in green. Now you can see on something like the M4 2 extra large, we're actually setting it to a reasonable value of like 500 megs for a large box. And on the very big boxes, you'll get as large as 4 gig, on a 244 gig box will be set for this. This will really help with just sort of all those maintenance activities. So of course, one of the things that was very important for us was to be able to support doing major version upgrades. So we released this a while back. You can have your production 9.4 instance. What we're going to do when you ask us to upgrade is we're going to take a backup, and then we're going to do PG upgrade. So this is the standard PG upgrade that you would all run if you were doing this yourself. Then we take another backup, and I'll explain why in a second. And in the end, you end up with a production 9.5 instance. Now, the reason why we take those 2 backups is there is actually no ability to do point in time during a PG upgrade. It's not a transactional event. It's actually kind of interesting in that it essentially just goes and does a bunch of stuff under the covers and then gives you this new database back, right? So we do the backup so that you can restore to before you upgrade or right after you upgrade, so you have that flexibility. Now, of course, you could just do this, but we don't recommend that being the best practice. What we recommend is that you actually upgrade, you make a test instance to upgrade, and then you go through and you do the upgrade, and you basically see the resulting instance, right? And then you can run your applications, you can check them out, you can make sure everything works before you go do the production one. And we've seen some oddities, and I've talked about them before on there's a few things that PG upgrade can have problems with, based on some issues with PG dump, in some cases. So it is really important to go and do this with your test instance before you go and do it with production. And then once you're happy, you go do it with production, it's all good. So let's move on to things that we've learned and changed in the security base. So this is your typical setup of a database. You have your application host, you have your database instance, and you have your backups. So this is very similar to what most people run, whether it's in AWS or on RDS. We start with the concept of security group around your database instance that allows you to protect who can come into your database. We allow you to turn on SSL. It's there by default, it's on. that you can use it. And then we have this thing called VPC, or Virtual Private Cloud, which you can layer around your applications, your database, to really control your network security. So these things really have a nice coverage on sort of your basic security. We then added encryption at rest. So we support encryption at rest for the database and all of the backups. So this means when you turn this on, one sort of setting, you get that protection of knowing that your database is encrypted. And this was all great, and then we had a lot of customers saying, this is good, you have this end-to-end story. And then we had a couple customers saying, well, hang on 1 second. What happens if my users set SSL mode disable, right, on their client? And we're like, oh, yeah, that will basically turn off SSL. And so then your whole story on end-to-end encryption is kind of gone, right? So we added a new thing called GUC called RDS.force_SSL. When you set that to 1, which you have to turn on, basically this forces SSL to be on. So now if someone tries to connect with disable, they won't be able to connect to your database. So this is really good if you want to have the end-to-end security policy. You can now basically ensure that everything is encrypted from one end to the other. So that was, again, a great request from customers to add some feature there. Another thing that we do is we allow you to basically share snapshots or your backups of your database with other accounts. So this is handy if you have like production and test in different accounts or just different portions of your company. So when you take a backup, you end up with a snapshot. You can say, hey, share that with another account. And then they have a snapshot that they can view, and from that they can create an instance. This is all great, but what happens if you've turned on encryption at rest, right? So we now have added support. You can share to public too if you have that kind of data. So we added sharing for encrypted snapshots as well, but it works a little differently. Again, we wanted to make sure that our security story here was very good. So in the same way you have your snapshot, but now you have a key, right, for your encryption. And by default, if you just turn on encryption at rest with RDS, you start with a default key. My recommendation is not to do that, because if you try to share your snapshot with a default key, that will not be allowed. And here's the reason why. Because your default key may cover all kinds of databases, all kinds of things. Someone thinking that they're sharing the key for that one snapshot is actually sharing the key for everything, right? So by default, this is not allowed. So when you go and create your instance with RDS with encryption, what you want to do is you actually want to do a custom key. And it's very easy to set up. You create a custom key, you associate it with that. Now that custom key can be shared. So you have to add permissions for that key to the external account. And you have to share the snapshot. So there's two pieces. What's really nice about this is you can actually separate these privileges out from a access policy method where you can say, Bob has the ability to share the keys, and Frank has the ability to share the snapshots, right? And so you can really make sure that no one's inadvertently sharing your snapshot with some other company or random account. And then, of course, once that's done, you can actually create a database instance. So this allows the flexibility to have prod and test in different accounts, for example, but still have a good security model around it. One of the questions I got a lot when we first started talking about encryption at rest was, well, what's the performance overhead of that? So, of course, we went and benchmarked it. The first benchmark is just pgbench, read-only, in-memory, transactions per second on the vertical. And then along the bottom, we just have increasing client counts, threads, basically. And what we see, of course, is that green is regular, blue is encrypted. We don't see any measurable overhead because the encryption is happening at the storage layer, and we're not doing anything with the storage. So, of course, we would expect no difference. For a read-write test, again, we're using pgbench. How many people have ever looked at the statements that pgbench actually runs for the read-write test? So, it's what is it, 4 write and 1 read? So it should really be like a really small R on the read and a really big W on the read-write test. So it's a fairly heavy write test, which is good. And so again, the same chart, regular and blue on encrypted. And what we saw there was about a 5 to 10% overhead on write workloads. And this is a heavy write workload, so this is probably more, not very typical for most customers. Most customers will probably see a few percentage points of overhead to run encryption at rest. And, if encryption is important for your data, it's probably worthwhile to do. Let's move on to things we've updated in the data movement area. So this was a big announcement that we did yesterday. We added logical replication support for RDS. So what this means is if you're on our new minor releases of 9.5.4 or 9.4.9, or in the future anything we release greater than that, you have the ability to do logical replication. So we have a parameter, again another custom GUC called RDS logical replication, and if you set that to 1, we'll go set a bunch of stuff in the background that sets the wall level and a bunch of things to make it possible for you to do logical replication. Then you need to connect to your database with basically a user that you've given both the RDS super user and the RDS replication role. And these are given to your master user by default when you start your instance. So then you essentially create a replication slot. In this case, you use pg-create logical replication slot. You have the name and what you're doing. Once that's done, essentially it creates a slot and it starts buffering the changes for you to pull. Now, one of the ways to pull that data is to use pg-receive logical, and here I've got an example where I just said, okay, connect to the Postgres database, use the slot name I gave in the example, and here's the RDS host name to use, and I say start it up. And that'll just start streaming the changes back to you that you can use in however you want. And we also added support for event triggers as part of this change. So one of the interesting things that I don't think a lot of people get about the logical decoding is that not only, of course, much like any kind of replication slot, while you're not pulling from that, it buffers changes in your PGX log, right? So if you go and do 3 gig of changes and you're not pulling from your slot, you'll have 3 gig of removable changes in your PGX log directory. And I'll talk a little more about that when we talk a little more about replication. But the one that most people don't get is that you also have space for the logical replication slot when it's basically transforming the wall into the logical piece. Now, this is normally very small if you're doing small transactions. But if you go dump in this case, an 800 gig transaction as a single commit into logical, what happens is it has to go read that out of wall and it builds that whole thing up in another directory on your Postgres instance. So we added another CloudWatch metric so that you could actually see what's going on here. Unfortunately, we actually missed, and this is not in the RDS console at the moment. You have to go into CloudWatch, although we're going to get that fixed right away. But it does allow you to see this other overhead that might be using a bunch of space on your instance if you're not actually processing, if you're processing large transactions. So the other piece that we support now that we support logical replication, is supporting DMS. So DMS is our data migration service, and it allows you to essentially either migrate or replicate data from any of those databases you can see. You notice how Postgres is first in that list. I didn't even make that chart. But you can go from any of these databases to any of the others. So you can go Postgres to Postgres, you can go Postgres to Oracle, Oracle to Postgres. And it really is a very powerful tool. So a lot of our customers are using it. I think we've done thousands of migrations. Customers have. You start with your on-premise database or an EC2 database. Your application's talking to it. You set up an EC2 or RDS instance. And you go and you basically add a DMS instance, right? And that's the little gears there. And you configure it by saying, hey, here's the source, here's the target, much like you would do with most replication. And then you go define, hey, what tables do I want? And you essentially start pulling data from and filling up the new database. Now, this is done as one single consistent select on each of the tables. And then it uses change data capture to keep up and to keep the data fresh until you want to switch over. Then you get to nicely switch over with all your data up to date, and you're done migrating. But you can also use this for ongoing replication, and I'll show some examples of that as well. So again, Postgres specific, up till our support of logical replication yesterday, the only sources were EC2 Postgres or your on-premise Postgres, that you couldn't use RDS as a source. That has now changed. Again, your RDS has to be 9.4.9 or 9.5.4, but then you can actually use this as a source. As I said, it does a bulk copy, basically, is a consistent select, and then it's using Postgres logical to do the change data capture, right? So no triggers, nothing like that. One of the reasons why we've added the event trigger support was so that it could capture DDL and other things so that you can actually replicate ongoing. If you want to read more about DMS, I've got the link there. It's got quite a bit of documentation around it. So what can you build with this? So let's say you have an RDS Postgres instance. You fire up DMS, and I just had a customer ask me, I really want a reporting instance, but I can't do that with my with read replicas because I need to change some indexes. I need to do a whole bunch of other stuff to my instance. And I said, well, just give me a couple days. We'll get this for you. So now you can create what I think of as a logical replica. So you can move some or all of the data, but you can have different indexes. You could have views, roll-ups. You can do anything you want, and it can be completely different, right? You could move the data to Redshift. So DMS is actually optimized to putting data into Redshift. So Redshift likes its data in bulk. It doesn't like little inserts. It's a column store. So how you want to load it is you want to go and say, hey, go load a big chunk of data at a time. DMS will do that, pulling out of RDS and then adding it to Redshift. You can go to on-premise Postgres. You could go to EC2 Postgres. You could go to EC2 Oracle or RDS Oracle. And of course, because we support just general logical, you could build your own custom logical handler, and you could throw it into some wacky NoSQL database. So really what this support means that you now have a way to get your data out and to see all your changes of your data on a real basis with a very little overhead. So this is something that our customers have been asking for a lot. So.
I have a question.
Sure.
Does this create the initial schema on the target, or do you have to do that manually?
You have to do that manually. I'll show some tools and some stuff that will help with that. So we have a schema conversion tool, and so this tool is meant mostly to go from one type of database to another, but can be used for a bunch of this kind of work. It allows you, with a client tool, to come in and analyze if there's any changes that need to be made from one schema to another to go from one place. So that can really allow you to do conversions. And we have a lot of folks very interested, for example, going from Oracle to Postgres. And the nice thing with the tool is it'll give you a very nice upfront analysis. So if your management ever says to you, we'd like to get off of database X to Postgres, you now have a tool that at least can evaluate and give you an idea about whether or not, how embedded, for example, you are with Oracle, how many things you're doing that aren't something Postgres can support. And in this picture, the green shows you the stuff that is essentially, it'll just happen. Like we can make it compatible. The yellow is stuff that you'll want to review, and then the red is stuff where typically it won't work, and you're going to have to do some custom changes to make it function. And in detail, it'll actually go and create like the functions and everything, and this is showing going from Oracle to Postgres in a detailed change there. So very nice, powerful tool. Won't do everything for you, but is a really good starter if you're looking at that kind of work. So if you combine that with the ability to do DMS now, or for example, like even going to Redshift, although Postgres compatible, doesn't have all the features, you'd be able to do, figure out what's different. So one of the other things that we've had a lot of conversations with customers about is with vacuum. The dreaded transaction ID wraparound is one of those very interesting ones, and I always ask this, like, how many people have had to deal with that, right? And it's like, if you haven't put your hand up yet, you probably will at some point, because you'll either hit a bug or some problem which will cause you to end up in this state. Hopefully not. So we talk to customers about really looking at the parameters, about auto vacuum and getting settings that work for them. I'm not going to go through each one of these in details. Jim Nasby's got a good presentation. Other folks too have done great presentations in detail on vacuum. All I wanted to say was this is definitely one of those areas where we've had a lot of work with customers. So we've made some improvements to our setup to kind of help with that. The first was that you couldn't actually see the logging that was being done for auto vacuum with the way our setup worked. So we've changed that by adding an RDS force auto vacuum logging level. So if you set that to log now and you have your auto vacuum min duration set, you'll actually start seeing messages that take like more than 5 seconds or errors in your logs. And this one's great because it's actually showing you, hey, it was skipping this table because it couldn't get a lock on it, right? So that's actually good information to know why you're not getting vacuuming done. We actually have a very good document that our engineer Sean worked on. He's in the row if you want to talk to him later. He contributed to this to our documentation on vacuum, and it goes through a lot of common scenarios that customers might have about how to look at vacuuming and keeping up to date. So the other thing we did was we made some changes on pgstat activity so that given our permission model, you could now see vacuuming. Before, you would see stuff like RDS admin is doing an insufficient privilege operation, not really that helpful to you. Now you'll see stuff like, oh, look, autovacuum is running on doing an analyze of this table. And this is sometimes important because folks are trying to manually vacuum tables, and they can't do it because autovacuum's running, but they can't see it because they couldn't get the activity. So this is another nice change. And one of our best changes, I think, which was we now have a CloudWatch metric that shows you the maximum used transaction ID. So this is the highest one out of all the databases. And you can essentially set an alarm or monitor on this now to see where your database is. And this is actually just a nice idea in general. Greg, you have a question? Yeah. So this is this is basically how much of the 64-bit space you're using. So it's an absolute number, not a So if you're getting close to 2 billion, basically you have a problem. So we tell customers if you're at like 1 billion, you might want to start looking at stuff at 1.5 billion. You want to start panicking a little bit, right? So this is the difference between the highest one and the oldest one. Sorry, the current one and the oldest one. Yeah, exactly. So yeah, it's basically the differential of those two. And the nice thing is you can kind of see slope as well on this, right? So you'll be able to see how fast I'm growing, what's vacuum doing, and it's actually just kind of a nice thing to have a long-term trend on this, which I thought is, this is kind of a nice thing to have in general, for your database. So that's been really helpful. Makes customer conversations much easier when we can point this out and say, look, you have a problem, we need to talk. We've had customers that had, 30,000 tables? 300,000 tables, with a very small setting on how many vacuum workers, right? So it just couldn't keep up. So it was making a dent, but it wasn't doing enough. So this really helped show that very clearly. Let's talk a little bit about what changes we've made around scale and availability. One of the things that we did was we released the M4 line in the last year. And I've ran, again, PG Bench, read-only, TPS again on the vertical access. What we see is that we see about a 37% TPS increase with this new model, and that's really nice. But the good news is that it's actually cheaper than the old model. So you save a little bit of money, and it's faster. So in general, this one's a 46% better price performance than our previous model. And I always tell this to people because I'm like, I want you to be running on the latest boxes. I don't want you running on the old ones. Move up, save money, makes my life easier, because the newer class of hardware is typically better and easier for us as well. So always be trying to look at our newer instance classes, because they usually will save you money and be more performant. One of the other real conversations we had with customers about being able to use RDS was a lot of folks said, look, I'm just not comfortable without having the details that I'm used to by being able to SSH into the instance. And then we sort of asked more questions and got down to a lot of people saying, like, look, I need top, I need VMstat, I need these tools that will show me these metrics. So what we did, instead of giving you SSH to the box, was we gave you enhanced operating system metrics. So essentially, all these metrics now you can see on a 1-second basis. You can set it anywhere between 1 and 60 seconds, and you can see all these metrics. I won't go through all of them. My favorite one is the process list. So this is essentially virtual top that you can look at, and you can see what's running. So in this case, you can see, oh, I'm running a select query, and it's using 3% of the CPU. If you had vacuum running, whatever, you'll be able to see those things using CPU on your instance. And the cool thing is this can be viewed historically, so you can kind of look at it over time as well. And here's what the graph looks like, as just the overall OS metrics. So let's say you had a big spike in CPU, and your manager's like, what happened? What was causing that? Well, now you have a lot of other metrics you can correlate to help figure it out. For example, in this one, you can see, oh, I had a big spike in the number of running tasks. So somebody probably kicked something off here and added a lot more CPU. So it wasn't a runaway query, it was more work being done, right? So it just helps with those kind of diagnoses. Another question we get a lot from our customers is what to set shared buffers to. Postgres is a little interesting because unlike Oracle and MySQL, it doesn't have just the single cache. It uses both its shared buffers and the OS cache. So we get a lot of questions on this. So first you need room for the Postgres processes. You need shared buffers, and we set that to 1/4 of the system RAM by default. So on an R386L, which is my example here, we're going to set that to around 60 gig, and the rest is going to be Linux page cache. So when you do a select of data, basically the Postgres process is going to look in the shared buffer to see if it's got those buffers. If it doesn't, it's going to go try to read them. That'll first go to the page cache, and if it doesn't find them there, in our case, it'll go to EBS, and then it gets returned all the way up. But as you can see, that there's a lot of extra steps involved if it doesn't find them in the shared buffers. And so that's why we sort of recommend that if you can, setting your shared buffers closer to your working set size is really important. Now you might say, well, how do I find out my working set size? Remember that extension I was talking about, PG buffer cache? That's a way to go look at what your buffer cache is doing, what tables, how much you're using to be able to help determine that. So ran a set of benchmarks. Again, PG bench. This is again TPS on the vertical axis. And what we're trying to do is look at, it's a read-write workload. And we started with the working set being 10% of memory. So in this case, around 24 gig. So on the bottom, what you see is different runs with different amount of shared buffers. So the things to the left of the red line are where we don't fit into shared buffers. And on the right is where we do. And then all the different colors are basically just increasing the thread count, 25, 50, all the way up. What we see, of course, is about a 5 to 6% improvement when we're in shared buffers, rather than having to go down to the file system cache. So it's kind of like, hey, no one's going to complain about getting an extra 5% performance. It's a good deal, right? But what's more interesting is when you go to a larger working set. So in this case, now we're talking about a 120 gig working set, 50% of memory. So now, when you see these, we get a much different story. On the low end, with small numbers of threads, we're seeing maybe 3%. But in the upper end, we're seeing more like a 20% gain by being in shared buffers. Now, the thing to remember about sort of the Postgres buffer cache is this advice is very good if you can get your working set fitting in shared buffers. If, on the other hand, your working set is much bigger than what you can allocate for shared buffers, then there's a lot of interesting sort of page replacement stuff that comes into play. And then, in that case, you really have to look at sort of possibly setting it smaller. One of the other things that we got asked to add a long time ago, and I'm very happy that we finally got this one done, is being able to put the stats on RAMDISK. So there's the PG stats that get stored in the stats temp directory. This creates some amount of I/O. Now, on a lot of instances, this is pretty trivial. But if you have a lot of databases and a lot of tables, this can be a little bit of I/O. So now you can set RDS PG stat RAMDISK, and it's in megabytes. You might set it to 16, 64 meg, whatever, depending on your size of your instance. And now it's just going to create a RAMDISK and point that directory at it. So a lot of people do this on their own systems. Now you can do it with RDS. Just wanted to get to sort of parity on that feature. One of the other conversations we have is we have these questions about sort of availability. How does multi-AZ compare with using async replication? Is it the same thing? So I like to walk through this just to make sure everyone's clear on that. Typically, you start out with your application, your database in one availability zone or one data center, if you're on-premise. But we really believe that it's important to have a secondary, to have your data replicated to another place. We also think it's a good idea to have your application running in both of those locations in case of failure. And for us, what we thought was important was to do physical synchronous replication. Physical because it's fast, it can keep up, and synchronous in that we'll know that the data is over in the secondary so that we can make failover decisions without having to wait. And we avoid split brains by doing that as well. So in the case of a primary failure, we're going to promote that secondary primary. We have DNS that we use, and the primary is going to actually update the DNS, which updates the CNAME, which is how the applications know where to connect to, and they will connect over to the primary. This takes about 60 seconds, which about 20 something of that is the DNS propagation and any database recovery. So once this is going, you're all good. And even if whole AZ goes down, you're still in business. And of course, once it's back up, we basically rebuild the secondary over in the other availability zone and get you going again. So you're fully protected. Now, read replicas can also help with availability, but from a slightly different basis. So we have our same application or same multi-AZ. We can now add read replicas with typical, just regular asynchronous Postgres replication. But what this allows us to do is, let's say you have a blog site. Well, you can split basically your application into two pieces. There's the piece of the people reading the blogs who they're fine getting eventually consistent reads. They'd go over into that yellow section. But the people writing the blogs, they need to read and write the things they're doing. They would be in the blue section. And this is nice now because remember when we had this failover, there's 60 seconds while we're failing over, your blog site would be unavailable for that, right? Now you can have those customers reading from your read replicas, and they're not going to see any effect. And then once this failover happens in 60 seconds, the people writing blogs can get back to that their day job of writing blogs. And this works whether you're doing an upgrade to your primaries. You can still be using your read replicas while you're doing that. And because you can have multiples of them, you can be modifying them and changing them and still have good availability. So we like this model of sort of combining read replicas with multi-AZ for additional availability. One of the interesting pieces is how we do promotion for read replicas, and I always like to call this out. Unlike a lot of setups, when you promote a replica, you just change that replica to a new primary, you can add an application to it. But notice it doesn't change any of the other replicas. There's no following, there's none of that. It just leaves everything exactly as it is. So you just have to be aware of that. Now you can go and do things with your new primary, but if you want, you can have the old stuff still existing. And the other thing that we released in the last little while was the support for cross-region replicas. So this really was an ask for a lot of folks for DR and other capabilities. So we have our same setup, but this time I'm showing the region US East 1, where I have my multi-AZ setup and a read replica. What I can do now is add a replica in a new region. So when you go to the console, you say create read replica, but instead of saying same region, you just pick a new region and you put it in there and it'll go create this. And so in this case, I created one in EU West 1. So I'm replicating to across two geographies, and I now have a read replica there. And we've actually had customers that have used this for both DR and to move, because sometimes we build new regions, and those regions are closer to the customer. So we just did one in Australia, so folks said, oh, well, I'm going to move off the west coast of the US down to the Australian region. So this is a way they can do that. They take their read replica, they turn off their application writing to their primary, they wait for those writes to go through, they promote the primary, and they start up their application. And they can also then, of course, configure all the multi-AZ and everything else, and once they're all done, they can essentially get rid of the stuff in the US East 1. And this is also how it would work in a DR scenario. You'd just probably be doing it a little bit faster because it'd be kind of an emergency. Question?
Yes. Will this work for cross-region? Will it work for encrypted yet?
The question is, does it work for encrypted yet? Not yet. It's definitely on the request list from a lot of our customers and something that we're actively pursuing. Obviously, we want our encryption story to be full. The interesting thing with doing encryption across is that in different regions, it's the sharing of keys that make things a little more complex, and that's the piece that is coming along. So the other thing you can do is you can also use cross-region read replicas for reducing latency. And so we have a bunch of customers doing this, where they actually run the application in each of the regions from a read perspective to give them better latency. So again, in that blog site, you can imagine instead of going back to the US from like Asia or Europe, you could actually have read replicas in each of those regions to reduce the latency time for your application. So we also see a lot of use of that. One of the things to understand that we've changed with the cross-region is how we actually do the streaming replication. So in region, we have a primary and read replica, we have streaming replication, but if that replication breaks, right, we start accumulating logs on the primary. Well, we started with in-region replication before slots existed, so what we did was we would essentially move the logs up into S3 and allow us to delete them off the primary, and then we would manually replay those on the replica. So this means that we can keep up with the replicas, and then we can put them back into streaming mode. So this works pretty well, although it's not as good as streaming. For cross-region, because of the nature of it, we went with the new slot model, which is one of the reasons why it's only available on the later releases. So in this case, when you're streaming, if streaming breaks, you will start accumulating logs on the primary. And if this goes on for a long time, you'll essentially run out of space on your primary, which would not be good. Now, you can monitor the space usage, and I'll show you that. But the ways out of this, there's a few. One, you can promote your replica, so you can still use it for reading, and it will no longer be holding that slot open. The other option, of course, is if you don't need that replica, is you can delete it, which is not usually the case, because if you didn't need it, why did you have it in the first place? And the other thing is to do whatever you need to do to get the streaming replication running again. And one of the things that I would point out that we have some customers do is they actually set max standby streaming delay to -1. How many people know what that does? How many people think that's a good thing to set on their databases? So what this does is it basically says delay indefinitely while there's a transaction, that's going to conflict. So what this means is you're basically, your replica can get infinitely behind, which in the case of having slots means that it will just keep accumulating logs. So this is one that you really want to be very careful with on setting, especially with something using slots. So as I said before, there's ways to monitor the space usage. So the first thing, of course, in CloudWatch, we have replication lag. So this allows you to basically see how far your replica is behind. Now, in this case, what I had was I had like a medium-sized instance replicating to a T2 micro. So you basically have a medium size and a really tiny instance, right? And then I basically did a big PG bench dump into it, like an initialization. Well, that caused it to fall like 600 seconds behind because, the medium was able to do the work pretty quickly, but then it had to go over to the other replica, and that took a while to get over. So you can see the lag, but this is what's actually happened on the replication slot. So we have another metric called oldest replication slot lag, which is kind of confusing name. It's in megabytes, so it's not really a lag in time. It's a lag in space, anyway. So this shows that the 3 terabytes or 3 gigabytes that we loaded basically ended up sitting in the PGX log directory waiting to be pulled by the replica, right? So this is how you can see not only how far you are behind in time with the replication lag, but also how much space it's consuming and holding in your Xlog directory. So with these kind of things, you can actually sort of see what's going on with your slot usage. And the other one I talked about last year when I was here, which is that I'm really still excited about, is really our burst mode. And I think this is going to be the key to some of the future cloud stuff. Burst mode essentially is the model of you get so many credits. If you don't use those credits, you can use them later. And for a lot of database work, this is really useful. So we have the T2 line, which is our instance classes, that essentially store up CPU credits for 24 hours, and then you can use them. And there's a metric for that I'll show. And on GP2, our EBS volume type, that does the same thing where you get 3 IOPS per gigabyte. So if you buy 100 IOPS, you get 300 gigabytes, or 300, if you buy 100 gigabytes, you get 300 IOPS. If you don't use those 300 IOPS all the time, you're storing those IOPS up, and you can use them to burst up to about 3,000. And I say about, because we sometimes use multiple volumes under the covers for RDS, so sometimes you can actually burst to higher than 3,000 with larger sizes. What does this look like in practice? This is the T2 credits, and you can see the orange line is where the credit balance is, and as I'm consuming excess CPU, I'm burning those credits down. And when I exhaust them at the bottom, you can see that drop in how much I'm doing from an actual CPU basis. So the only unfortunate thing is at the moment, EBS does not have a metric for GP2 and its credits. It's something that we're working with them to try to add. One of the reasons why I brought this back to my slide deck was we actually introduced a new model called the T2 Large. So this is a bigger box. It's got more credits, more base performance, 8 gig of RAM. So anyone that says these are small boxes, They're not really that small anymore. It has, oh, there we go. Corporate computers, nice. It has increased I/O bandwidth, so that means you can do more, basically, EBS work. But the big one that's really important is it's got encryption at rest support. So when we were talking about our complete encryption story, it's great that we have this end-to-end encryption story, but if you can only use it on our largest instance classes, then when you want to copy something down to test, you were like, oh wait, I can't do that because I can't run anything with my encrypted volumes. Now you can use the T2 large to basically do your testing on. So I'd run a bunch of benchmarks to kind of see the price performance of these models. So I ran a benchmark with transactions per second, and I ran it on the bottom. You can see for hours. So I run it for 24 hours. So the first thing was to take one of our really old instance classes that we still sell and people still order, the DB M1 Medium, and 200 gig of our standard magnetic storage. And we basically get around 1,700 IOPS, and it costs 58 cents an hour to run that. We go with a more modern system, and I need to update this to the M4, but this is the M3 Medium. And this time I bought the provisioned IOPS. So this is sort of our Rolls Royce of our EBS storage. I bought 200 gig with 2,000 provisioned IOPS. And we can actually see what's interesting here is that even though you'd think we'd be spending more for the provisioned IOPS, the M3 Medium difference in price is actually offsets it. So we end up with 40 cents an hour, and we're up more like in the 2,000 range. So we're actually getting better price performance. But then let's add the M3 large. Let's go to a little bit bigger box. We get a little more caching, so we need a little less I/O. Same storage. What's interesting with this one is, and I didn't even really plan this, was that I get 25% better performance, and it costs 25% more. So it's kind of like, well, that's OK. But then let's look at the T2. So in this case, we're going to go with a T2 Medium and 200 gigs of GP2 storage. So this gives me 600 IOPS, guaranteed, bursting to 3,000. So what we see is for the first couple hours, we get really good performance, like above 3,000 TPS. And then it drops down. Well, why it drops down is we ran out of GP2 credits. And you can see that we're not getting that many transactions. But look at the cost. It's 10 cents an hour, much cheaper than any of the other options we've examined so far. So the nice thing with GP2, though, is if you want more IOPS, you just buy more storage. So what I did was I bought a T2 Medium with a terabyte of storage. So this guarantees me 3,000 IOPS. Now you'll notice it's 23 cents per hour. Now it was doing 6,000 TPS off the start, and then it drops down after it runs out of GP2. And then you'll notice out there at hour 17, it drops down again. And that's where it actually got throttled on the T2 instance class. It ran out of CPU credits. But notice where I'm comparing there. I'm comparing now that M3 Medium versus the T2 Medium. And they're getting, even at the end, they're getting about the same TPS, but one costs 40 cents an hour and the other costs 23. So you're basically getting almost twice the price performance by running this burst mode model. What's cool is we added the T2 large, right? So I went and reran the benchmarks. And in this case, I'm getting 12,000 TPS for the first hour and a half. So that's pretty remarkable when you look at the cost. This is a 30 cents an hour setup, and I'm getting, almost 4 times the performance of the M3 large, right? For almost, again, half the money. Now this drops down, but it runs out all the way even out to hours 21, 22 at over 5,000 TPS. And if you can imagine that you're, scenarios where you're running a database, you need to do, an analyze, an index build, you need extra CPU for doing something, but you don't need it all the time. These burst mode models can be very, very cost effective. They can really help you change your game on how much you spend because you no longer have to pay for all that excess capacity that you only use once in a while. Yes, Greg?
Is this the steady state or will it keep dropping?
Well, so again, this is the state where when you have credits, this is the sort of starting state, and then you would need to not use it for a while again, and then you'd be able to to go again at the.
At 12,000, but would you be able to maintain it at 4,000?
Yes. So that bottom, the far right on the 24 hours, that would go forever. So that's the baseline. So even the baseline on these is quite good, right? Yep.
But if you're running at that high speed, you don't earn the credit
Right, yeah. So if you were running just at the max, you wouldn't be able to burst again. But you can see that even running at the basic rate, you're still doing quite well. And so I think there was sort of a myth about the T2s that their sort of base rates weren't very good. And as you can see, that they actually are quite good at producing a reasonable number of TPS, especially when you consider the value. One of the other things that we just started was we started a new blog specific for databases. This was another comment that customers were giving us a lot that said, boy, you guys release a lot of services and a lot of changes. And that's great, but I mostly deal with databases. I'd like to be able to have a focused place where I could get updates on what's changed. So that's a great place to go. The announcement that we did yesterday, so if you want more details on that, you can go to this site and it's there. And if you have any comments about the kind of stuff that you'd like to see us blog about our services, welcome that feedback. And with that, I'll take any questions.
With the logical stuff you added, how many different plugins or what are the plans for plugins?
So the question is, for our logical stuff, what are the plugins? Is that was the question? Yeah, so at the moment we're just using the basic one. I think once PG Logical gets to a more done state, we'll probably look at adding other ones as well. But yeah, it's this was sort of our get it going, and then we'll kind of based on customer feedback we'll look at what else we'll do. Is there a question over? No. Okay. Other questions? Okay, well, thank you very much.